Alright, let's look at an example of a free undamped motion. Alright, here's the initial value problem. X double prime plus 4x equals 0. And the initial conditions are x of 0 is equal to 1 and x prime of 0 is equal to 2 square root of 3. Alright, so let's start with the characteristic equation. So characteristic equation is r squared plus 4 is equal to 0, right? Which gives us r is equal to plus or minus 2i, right? So the solution is going to be, general solution is going to be x of t is equal to a cosine of 2t plus b sine of 2t. Alright, so we got that. So using the differential equation, we can do this much. Alright, so let's use the initial conditions to find the constant a and the constant b. Alright, so by plugging in t equals 0, so we have x of 0 is equal to, alright, cosine of 0 is 1, so you're going to get a. And the sine of 0 is 0, so it goes away. And it's supposed to be equal to 1, right? So we already found a using the first initial condition, right? Let's use the second initial condition. So first we have to take the derivative. So we're going to get x prime of t is equal to, right? So you have a, just a constant multiple, right? Then the derivative of the cosine of 2t is negative 2 cosine of 2t using the chain rule. And plus b is a constant. And derivative of sine of 2t is 2 times cosine of 2t. Alright, so we can plug in 0 in there. So you have x prime of 0. So in this case, let's see. Oh, actually messed it up. Here it's not cosine. Sorry, derivative of cosine is going to be sine, so it's going to be sine here. All right, sorry about that. All right, so if you plug in t equals 0, all right, sine of 0 is 0, so it goes away. Cosine of 0 is 1, so you have a 2b here. And we're supposed to get 2 square root of 3 using the second initial condition, right? So by dividing through by 2, we can get the b value. So b is square root of 3. All right. So we have the complete solution. So it's going to be x of t. So a came out to be 1, so it's going to be a 1 cosine of 2t, and b is square root of 3, so it's a square root of 3 sine of 2t. Alright, so we can find the amplitude. C is going to be simply square root of a squared plus b squared. So we're going to do square root of a squared, which is a is 1, so 1 squared is 1, plus b squared, b is square root of 3, so it's a 3, so it's a square root of 4, which is 2. Alright, so we found the amplitude. And circular frequency is just simply 2. So it shows up here and here, which comes from the solution of the roots of the characteristic equation. So circular frequency is 2. And actually, we know the period too, so it's going to be a 2 pi over 2, so which is going to be pi is the period. All right, so let's pull out c, which is 2, so that we're going to have, right, 2 is outside, right? Then what you have is cosine of 2t, right, times 1 over 2, right, and plus sine of 2t times square root of 3 over 2, right? And we can rewrite it as, remember that we look at this guy as the cosine of alpha, and look at this guy as the sine of alpha. Then we can make it look like this. You have a 2, so this is the amplitude, and you have a cosine of, right, 2t minus alpha, right? Right, where alpha is going to be, so in this case, A happens to be positive, B happens to be positive, so the angle is in the first quadrant. So this is going to be simply arctangent of B, which is square root of 3, over A, which is 1. Right? And the arctangent of square root of 3 would be pi over 3. Right? So what we get is x of t can be written as cosine of 2t minus pi over 3. Right? So phase angle came out to be pi over 3. Right? So that's the solution of the a given initial value condition. All right, that's it. I hope that this was clear.